welcome to part one. This is the modeling section. I'm going to give you a quick overview of what we're going to achieve, and we're going to be going through and exploring a few different areas of Solaris and procedural modeling and texturing, LOOKDEV lighting, some effects. So we're going to be looking at creating some procedural like sweeties, some like love heart things. We can see they're kind of like tin foil covered in there, and this is all procedurally generated. So I will go through this process and I'll show you how we can create a nice simulation of a pile of sweets and then randomize the textures and things like that later as well. So if that's something you're interested in, please do stick around. So we'll go into the modeling section, and I'm working in LOP networks inside of object level. So here we are. Now this might look a bit intimidating, and it might also look familiar to you depending on if you see my previous videos. The setup I'm going to just quickly explain. First we want to generate go into SOP level here. So as you may notice, I'm working in Solaris under like modeling, just so I can kind of keep organized. Even though I'm an independent artist, I'm attempting to work within departments as much as I can and try to keep organized. So I've created a digital asset here that will basically inflate the results of a curve. So we'll input a curve like so, like this, and the digital asset will essentially mirror that across. So here's the digital asset here, and I'll just open that up. The UVs can be a little bit slow on this process, but we're not actually going to be using the digital asset directly. We're going to be using it within TOPS. So I'm going to basically provide a set of hand-drawn curves, and for each curve I'm going to mirror and create a planar cloth surface, front and back, stitch it together and inflate it, give it UVs, and just create a model from that. I'm then going to vary some of the Vellum attributes, some of the attributes like just how long it inflates for, so maybe the quasi-static simulation frame range, so you get different like shapes across the profile. So I'm just waiting for this to resolve, and then I'll talk you through it. First we draw a curve like so, and I basically just made sure the start and the end point are directly on the origin, so that when this mirrors there's minimal kind of snapping that needs to be implemented within the digital asset. So I'm going to dive in and show you the digital asset, because this is what's going to be responsible for creating those shapes, those initial shapes that we have here. It's just going to create a thing like this. So you can see they're all slightly different shapes. We'll discuss the material and shading later on in a different video. So you may notice I've promoted a few top level things here. I just need somewhere to save the actual asset. So the digital asset, it runs standalone, but it'll also run in TOPS as well. So I could just manually do all of these. I could have like 4 of these and save 4 things out, and then take that into Solaris and start creating variants. But I wanted to create a bit of a workflow and become more familiar with TOPS, and create a bit of a workflow where I could create a digital asset and provide an input and actually have TOPS just pick up all of those inputs from SOP level, and then load the digital asset from the disk and take certain attributes that I promoted and randomize and create different variations of them. So you'll notice right now my machine I'm on my MacBook Air, so it's not super fast, but it's a good way of just making sure things are quite optimized as well. So you can see down at the bottom it's simulating, and it's simulating like only 5 frames, so it won't look particularly great, but it'll be enough to show you the results, I think. So I've declared how many frames I want to simulate, and I'm going to simulate in a quasi-static mode, and that just means the timeline doesn't progress, but it just resolves up to 4 frames kind of on the spot on the current frame. And then we've got a mirror curve, so it's going to make sure that curve gets mirrored first, and it's going to do a triplanar surface and front and back, and we're going to create stitches around the outside and just inflate this, and then it's going to create UVs as well. what will happen is we will have the curve, and then it will input and it will spit out this. Now you can see it looks very crumpled. That's because we didn't let it inflate long enough. So I'm going to just quickly pause the video, and it needs a minimum inflation of about 10 frames, and then you'll get this nice inflation going off in there. Okay, so I've changed that to simulate for 10 quadratic frames, and we get this kind of quite dense mesh with UVs on front and back, and that's essentially what we're going. This is what this digital asset does. So I'll go in and I will, just to stop things from calculating, I'll just set it to manual, and I'll go in and I'll unlock this, and it's a very simple digital asset, really nothing too fancy. We input a curve. Now if we don't have a curve, there's a temp curve in there already, so there's an expression here which is the op exists and then the op input, and if it doesn't find anything, this switch node just goes and grabs this. So it just means the asset is kind of like, will work standalone without any user input. We then resample the curve and we create a route. Let me auto update. So yeah, there is the curve from me in here that I drew, and here's a temp curve as well. So this is what the switch will do. If it finds a curve, it'll switch over to the one I've given it, and then we'll just resample that curve. I haven't promoted it. I could promote loads of things. I haven't needed to for this case. We create a route down here. Can't remember why. Then we mirror this across and we just fuse it. Basically, we just make sure that these are fused together. That's why when we draw this curve, we make sure we're like looking at it from this view, and we draw the curve. There is the option to mirror or not to mirror the curve. We don't really use that. And then we'll do this triplanar, this planar patch from curves, should I say. So we get this. So essentially get one thin surface, and then we do a transform. I'm just transforming this to this like that. And then we're going to do a reverse. And we're going to create a pin for the top. Group expand if we need it. We didn't use it in the end. And we'll do a soft transform. The soft transform is, I don't know if you can see, it's just lifting that up ever so slightly, just like that. And we do the same on this side, like so. So you can see we get, and we've got this group top and bottom, and then we'll merge it together. You get this like super flat thing. And then we'll do the auto UVs, which could be quite slow on this machine. So the tutorial isn't really about creating the world's most amazing inflatable object. I mean, I know sidefx have recently released a tool that kind of does something far superior to this, but this tool was like sitting around in my OTL library. So I decided to just bring it to just reuse it out of the box, because I used it in a project a while back. So I'm going to create a Vellum setup now. I'm going to get basically a Vellum constraint for the pin top and pin bottom, which we created like up here and up here. And that's going to pin this, stop it from inflating. And then we're going to weld these together as well. I'm going to create a Vellum cloth like so, and then a Vellum pressure. And then finally it goes into the Vellum solver, and that has been, there are a few parameters that you may have noticed have been promoted to the top level, which is the quadratic frame, and I've just got a couple of settings in here to resolve that, and that'll do the inflation. Then it goes into post-process, which is just adding a little bit of blur. We soften the normals, and then we just clean up any unnecessary attributes down here. Now my computer is trying to resolve this, which is a bit annoying. And then we would normally just cache this out and that is it. That's pretty much the digital asset. So I can go ahead and just clear out any unnecessary nuisance that I don't need in here. So again, as you can see, it's a very, very simple digital asset that just does one thing. That's it. All right, so just press U, and then I'm going to go to type properties. I'm going to click apply and accept, and I'm going to match the current definition. So we have this now on disk. So we have this. You can see where your digital assets live. You can see up here, and if you don't see this path, I think you can get that from up here. So I think it's along here. So if you hide, you might have this by default, but you can go in and find this. So it's always showing you the menu. So if you have versions, you can drop back and forth, but you can see the version of your digital asset as well. So it's that path that we'll need in TOPS later on. Some weird screen recording nonsense going off here. Anyway, so we're going to basically take these curves here and we're going to put them into TOPS, and we're going to use a few attributes on the digital asset, which I'm going to pause. Sorry, I'm not. I'm going to bypass, because this is just showing you the digital asset as it currently works independently without any TOPS. There we go. I'm going to show you the top network now. So as you may notice, I've drawn a few different curves, and I want to kind of use these curves to automatically plug into this digital asset here. So there's the first curve, and they're not very different, to be honest. There's the second curve, there's the third, and there's the fourth. And then I'm going to use TOPS to switch between. So you may notice a couple of things here, which we'll talk about in just a second. Okay, and you may notice this spare input as well. This spare input is just something that I added up here. You can just add a spare input, and then I've written an expression which counts the amount of inputs that this switch node has. So there's just 4 inputs. I'm going to use that as a way of counting how many things to iterate over. So if I dive into TOPS now, we're going to create a wedge curve, and we're going to basically create an attribute name called curve input, and this wedge count here is linked to this. So I'm just going to grab this curve input, and this is basically going to create a wedge for how many curves we're inputting. So this is kind of where we're doing that. So this here is this spare input that we worked out up here like that. And this variable -1 is going to go between 0, 1, 2, and 3, which will be 4 inputs like that. So Houdini on the next step is going to ask for like the geometry. So what I've decided to do is this to TOPS is basically this node here, and that's saying give me that geometry into here. So if I go and I view the dependencies for the selected node, you can see there's relationships between here and here. So back inside the top network to TOPS is this guy. So bring this in to here like so. And then before TOPS can bring stuff in, it has to save it out somewhere. So I'm just going to save it out. And it's important to make sure you're using the index, kind of the attributes from TOPS, the pdg_index. And I'll explain what that does in a little second. And that's going to do that. And essentially that's going to just go and fetch those curves in 4 iterations. And then the next thing it's going to do is plug this in to, we're going to create a wedge called sim frames. And I'm going to have a value that's between 10 and 25. So that's basically how many quasi-static frames I want to wedge between. And I want to create 10 wedges. So for the first curve, I want to say give me 10 versions of random samples between 10 and 25. So some of these love hearts will be, for the first curve shape, will be inflated between a value of 10 frames and 25. So it just gives a little bit of variation. I could have chose to do this with other Vellum attributes, but I've just chose to do the costatic frames. So this attribute variable here is sent back out of TOPS. Sorry, it's not sent back out of TOPS. It's sent to the digital asset. So you can load in your digital asset from disk here like so. And you give it an output. Like I'll talk about this in just a second. If I can just maximize this, and maybe this viewport is being very weird. Where's the parameters? See if I can. So we're loading the digital asset, which will do that. It will then, when you update the HDR parameters, it will grab all your parameters that you've got in here, and we can use this simFrames variable here, which is basically, this drives the amount of costatic frames, how many frames are going to be simulated on the spot. So that's the only thing we're changing really. And I don't need an output path, because the actual HDA processor, you can provide an output. So I've created a folder specifically named after the operator, which is going to be called heart, and then it's going to be wedged. So you'll see that it goes to something like this. So it goes into the name of the project, assets, geo, bgo, heart, and then it'll be heart 30 in this case. But yeah, so I hope that makes sense. So the last thing to do now is to let's have a look. Save the file, generate the static work items, and we should soon start to be able to see this kind of working as well. So if I start to cook the output node, it's going to go ahead and start grabbing all the curves. In fact, that would be pretty quick and instant, I would imagine. So if I went to the directory where this is being saved, so I'm in the project structure for here, you can see it's created a thing called curve, and it's created those curves named accordingly. So it's going to be those things that it uses to generate the geometry, which will be saved in here as well. So as soon as geometry has been simulated, it will be saved in here. So we'll end up with about 40, I would imagine 40 shapes. So this is going to take some time. So I'll just let this resolve, and then we'll take a look at the folder and see what we've got. So essentially that's going to give you the geometry variants that we can create a USD from and shade and do some nice stuff with. So quite not too complicated, but it's something that is it's a very useful feature to have. So this is kind of like part of the procedural modeling process. So as this is progressing through, we can actually view the output of this, because I've linked it to here. So this file node here is actually being referenced back in to the output of this node. So the results of these are actually coming out of TOPS and just being brought into SOPS. But they're not frame dependent, they're actually task dependent. So if you click on them, it will initialize the correct one to be viewed. So for example, if I was to look at this curve, which didn't exist on disk now, and I select this, I can select the first 4. You see that? And it's just loading them from disk. So we'll be able to apply the same logic here just to do a sanity check. So as soon as this goes dark grey, you'll see that we get the first love heart being saved on disk, and it should have the UVs and everything like that. So then we should be able to now go back to the hard drive and see the folder called heart that we've created, and it's going to create heart 01, heart 02, heart 03, heart 04, blah, 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 all the way to 40. And they're the things that we will put into LOPs, and we'll make a USD geometry variant out of them. So I'll come back when that's finished and we'll take a quick look. So I'm hoping you can see that this is quite a nice way of automating something. So you can take one of your favorite digital assets, and if it required user inputs, you can still gain access to that via TOPS. If it doesn't, then you can just do it like straight out of the box, I guess. We're just using a digital asset standalone kind of thing and creating your own variable. You have wedges and things. Or you could even set it up so it loads these from disk. There may be something from disk that you want to load in and do something to. You might want to like load in a bunch of geometry and fracture it, for example, and save that to another folder. So it's a very simple setup, but it does take this particular machine quite some time to go through. But as you can see now, it'll start to show you the different variations. Now, the first row will be the input curve 1, so there'll be no silhouette change until we get to the second row. So all of these tasks here, these dark green ones, are the ones that are finished, and all the ones that are light are the ones that are processing. So if you've got a really fast machine, this, like on my other machine, this will have been done in like 10 minutes or something. So it's probably going to take this machine about 40 minutes because it's just a MacBook Air, isn't it? And it isn't like made for this kind of stuff. I'm kind of pushing my luck really using Houdini on this, but I will switch over to my main machine very soon. So we should start to see, if I click on them, and each one of these will get a different, like, not a great deal, but just enough to kind of create a difference. There'll just be a different inflation rate. And we could always go back and change this to kind of change the rest length and things, but that should just be okay. It should just give a bit of variation. Some look very similar because some only inflate from a range between, well, for whatever we set here, between 10 and 25. So the chances are we're not seeing much of a difference there. We could also set, go back in there. We can also set a specific set of ranges as well. So it's really powerful, this. So if you know there's certain ranges that you want to randomize, you can do it that way. But it seems to be going through, and you can see the different inflation rates slightly. Not a great deal, but it'll do the job for now. Right, I will be back when this is finished, and we'll continue on to the next part, which will be bringing this from disk and making a USD variant for every single version automatically from disk. So stick with me. Thank you. Okay, it looks like TOPS is finished. It did take about 40 minutes, but again, this is not on my main machine. So we can look here, we can click on this, and it's actually taking the link down to here. So the expression that we're having here is basically resolved based on when I click on this, which is really nice. So you can see we've got a few, it's not super obvious, to be quite honest, and I should have used a slightly different method, maybe rest length, but we have a slightly different inflation and wrinkle, broad wrinkles, I guess, on here, and some may be the same because it is just random. But the second stream, we get the other shape, and we get the variations in there, and then another shape with a few variations in there. Okay, so these have been saved onto disk, so they live down here. So they're in a nice folder, and they're all BGOs. So I want to now take this folder, and back in Houdini, I want to dive back up out of this SOP network, and we're now back in the LOP network, the modeling network, and I want to take the geometry. So I'll just quickly show you what's happening here. So you can already see it looks very strange. It's the proxy version here. So it's the proxies. If we do final render, you can see it's in here. So what's happening is I'm taking the component geometry here, and I've created a little controller here, and I basically use a point to the folder I just showed you previously, and I've got a Python expression which just counts the amount of the amount of geometry in there. So this is the Python expression. So it's going to look at this control here and evaluate that, and it will also evaluate what's inside this path here as well. So it will kind of filter out OBJ, BGO, and BGO.sc with compression. So this basically searches the folder and counts the number of assets. So that's going to be what I use as an iteration values. So if we just dive into the first section here, you'll see that this expression here is linked up to this asset path here like that. And then I'm just going to quickly do a temp scale. So I scale this down a little bit. Let's just hide this. And then I created an attribute called sides. So, and that's just helped me with shading later on. It was a bit of a last minute thing. See if I can show you that there. So that sides attribute, if we click on here, we could just take a look. It's just an attribute which should just be basically, yeah, there you go, front and back essentially like that. So, and then I just clean up any attributes I don't need. So it's not really doing anything fancy in there at all. And then I give it a name called surface, and then I poly reduce it. So this is just the standard component geometry stuff. I also then created a convex decomposition just to create a piece of sim geometry as well for later on. So that's what's going to happen, is this is going to get looped round within that folder, and then it's going to come into each one of these, and it's going to go inside here, and it's just going to go and create a variance. There's a bit of Python in here again. Like so. And I'll credit the person I stole this from as well, and I'll point to the video. So I'm not claiming this is mine. I've just modified it a little bit. But essentially what this does is this cycles through and creates a variant for each piece of geometry it finds on disk. I did invent a little thing to do lodding, which I used in previous projects, but I'll leave them in for you to take a look at, but it's not really going to be part of this discussion at this stage. So then I'll set a default variant like so, and that's pretty much taking the files from disk and creating a variant. So if I take a look at the here now, you'll see that I have all these different variants which we can switch between. So I should be able to choose the model variant. Then we put this into the hierarchy. And the next part is pretty much just adding a light rig and a camera so I can quickly take a look at this. Now my screen recording was playing up quite a lot, so I'm hoping that I can roughly show you the LOOKDEV variants now. You can see that, well, it's the modeling variants really, so let's just rename that to model variants. And you should see there's different shape, ever so slightly changing. Like so. And then if we click on here, we'll be able to access the built-in camera that comes down from this stream. So just to recap, we have a SOP network where we can create the digital asset, then we can save it to disk, and we can create some inputs and run it through TOPS and create a bunch of assets on disk. We can then bring this in, and let me just quickly try to figure out why this is misbehaving. I wonder if it's the video recorder. It seems to be the video recording. So yeah, we can kind of get a turntable which we can then render, and there'll be no shaders on this or anything like that, but you can just at least see the model. Then we can go into here and we can opt to choose to a different variant, and you can see that kind of working as well. So we could cycle through the variants as much as we want until we get past the variant, the limit of the amount of variants there. Okay, so it seems when I'm screen recording, it's stopping Houdini from interacting with certain things when I have a full screen. So that's why. So we're going to take this now. I'm just going to save it to disk. I'll maximize. And you can see I've got this like link to the asset here, but I'm actually not going to use that. I used to have this linked. So if I go view, show for selected, you can see it's linking quite a few places. And to be honest, we don't need to do that. We could actually create a variable like an alias, which I did do, which I called asset name, and I called it heart, so I could just refer to that at any point in here. I could refer to that, but it's the same thing really. So you could have actually just gone like this. You could just replace this, which is a link to this, by the way. We could link this to dollar asset name, hit tab, and just make sure we've got one of these here, and you get the same thing. So it's one less thing it's linked to, and it probably looks a little bit easier, so easier to read, I guess. So rather than changing it here, you can change it in your alias and variables as well. So we can put that in there like so. And you can see I've used it quite a lot around here in the earlier days, so it's probably not actually required. It can be a little bit messy, that. Yeah, I'll not fix it, but you get the idea. So it's kind of referencing an alias. So if we save this to disk, this is going to go to this location. So it's basically, I'll just save it to disk now. That's just saved a USD to disk, which will be, it will be in under the asset now called heart, which has just been created, and then modeling, and then asset, the version, and then the name of like the actual USD asset here. So, and that's all derived by these expressions here. So op name is basically grabbing this here, just so it's kind of a bit more automated, and the rest is just derived by these strings in here as well. So you can choose to do a lot more with this, but I just wanted to save the model out, and now we have a USD of the model. So just to confirm that, we can check the geo there and check a variant to make sure this is reading in from disk and it's all fine. You know, we can do an asset reference, so we can change it here, and then we can check the modeling variants, and you can see that they're all just kind of nicely presented in a line there. So it's just a nice way of having a digital asset that automates an input and essentially just gives you a variation of stuff. So you've got a nice clean modeling asset to go to town on now. So the next part is not really essential. I am literally just bringing in two assets here like so, and you've seen this before, I think, the previous tutorials, so I've just literally got a camera and it just brings them in and it just does some rotation and stuff like that. So there's no shaders on them either at the moment. It's just another way of presenting the model as it is for now, so I can just take a look at it. And I've got a light rig built in here as well, so, and that's all kind of in the file as well, so it's kind of, it can be saved as a reference, so you can just have a play with that as well. So I'll send this light rig out here to my LOOKDEV section, and the reason I'm doing this is I'm saving out this little layout here down here, so I'll just save that out, and then I can pick that up and I can just start doing the LOOKDEV with the same camera and the same light rig and the same camera moves and everything, and it's a little bit more, hopefully a little bit tidier. So you've got like the asset generation part and then the presentation part, which can be expanded upon. And then we can switch down to LOOKDEV. I'll just turn off Karma for now. And we essentially reference in the results from the modeling department. And where is it? Let me take a look. So I'm actually going to just copy, I'm going to just save this again. I'm going to copy this and I'm just going to send this straight out to LOOKDEV. So I'm going to paste the relative reference in there. So we should see that. Why don't we see that? Okay, so it's a viewport bug. All right, good to know. So it's time to do a bit of LOOKDEV as well now. So let me just double check something. Yep, okay. So I'm putting all my USD stuff in here. It's a bit disorganized, but just for me, it's fine. At least I know that this asset and from this department and this version has the heart asset and the layout and the other transformations that I need and the payload and everything. So now I'm going to go in and I've created 3 very basic materials. So what I'll do is I'll just quickly skip past these 2 sections here because we've got some materials being built in LOPS as well. And we assign the materials in this for each loop, like so, and then we just set a variant, and then I put this through the light rig, which is brought this in from, here we go. This is exactly the same as the camera from the modeling department. So, and we have a quick light rig in here as well, so we could quickly take a look and get a quick look and change the variant as well as we're looking at things to see. Oops, did I use the same variant? So yeah, I can see there's like a 2-sided thing going off here. There's like got something going off there, and then we've got another one here, which is this. So nothing fancy, but I'm going to talk you through those shaders. The LOOKDEV variants, again, is just a quick way of putting a light rig on here, and this is just me taking a look at the variations that we've got. Now the shaders can do a little bit more than what you're seeing here. They can be varied from attributes on points when they're instanced as well, so you'll get variation and color variation on there as well. So if I save this to disk, you'll notice that this goes to the LOOKDEV folder under the heart asset, and we'll get the same thing. So we get this, and we get all the variants in there in case I want to use them in the layout LOP as well. And that's because I've enabled that in the output here on this section. So I've said, give me the model variant layers. So the rest is just sanity checking, basically. So what does this mean? That's okay. That should actually just be, that's a mistake on my part there. Sorry, I'm just going to quickly not have that connected. That was a standalone thing. So this is kind of live, and now this is on disk. So there it is. So it's just checking that it's there, and it just works. So we can render this with no lights, and Houdini will still. So we'll need to change a few things first. So we've got the actual geometry, and then the material needs to exist. So there's the material. Then when we set the variant, we just need to make sure it does exist. So there you go. So there's the first variant. Again, there's no lights. There's the second variant. There's the third. So that's that. So that's just data validation, just to confirm that I've published them. But what I'm going to do is I'm going to use the fetch LOP, and I'm going to point it to this thing here, which is live. Okay, and when we do that, it's going to bring in the heart asset, and then I'm going to pipe that in to this asset reference. Now, if I don't use this asset reference like this, then it will still work. It's just, this is just linked to the very actual output on disk here, like that. And then I have control over which version of the model I choose to display, like that. And then the layout is coming in from, if you remember, that's coming in from the modeling department. So this is what I saved out back up here. This is what I saved out down here, like so. And the idea behind this is I can just quickly take a camera and just have a little look at what's going off on these things, and I can cycle this round and have a nice turntable and things like that. But what I liked here is you can use this method, which links directly to the actual LOOKDEV like section here, and if I pin this, then you can see that I could manipulate the shaders that are actually being rendered live and get some interesting results. Or I could choose to branch over here like so and do the same thing and create a little instancing setup. So I take this and then I basically explore the variants, so all of the model variants. I create a collection and a light, and then I instance them onto some points like so. So inside of here, we're instancing onto a grid, we're scattering, we're creating an ID. My shader will use the ID, and we've got a little expression here that just loops through. So it'll just loop, it will actually loop the frame range. So if it's 50 frames, it will actually loop. So if you did a render, then when this thing's finished spinning, it will actually just loop. This didn't finish this render, like so. And then this part we'll talk about in just a second because it's referencing something within the shader. So we have this little setup here, and we can take a look. And this is all live, so you can see what's happening now. So I know there's a bunch of switch nodes in here, and one's pointing to the off, which is just basically pointing directly up here like so. But you can see, we can see the variations, the variations of the materials we've done here. So this is actually one variant that's been changed. So if we were to find the actual variant that's actually active right now, it's material 3. So if we were to go and have a look at material 3, so if we come all the way back up here to material 3, which lives in this material library, this is this guy here. So I'm bringing in the sides attribute and I'm using it to mix between this color red, and I'm randomizing the red with an ID, and I'm changing the saturation. So you can see the red side, I'm manipulating the saturation a little bit, so it sometimes looks kind of rose gold to like this deep red. And then I'm just sticking on a color value here and using a material geometry property value and just changing that here as well. And that's pretty much it. I'm just changing the color, so it's just a bit of randomization there, which is quite nice. So it's a really simple shader, and you can do all sorts. You can randomize the specular roughness, and you can just use maps on the geometry and all sorts of things and attributes to do this kind of randomization. So it's quite nice. You could add a seed here. You could just add an add in here, mtl add, and then we could create a seed so it changes. So you can see it's going to change the contribution of this shader as well on the red side, because it's coming in on this side on the material mix. So this sides attribute is the thing we established back in SOPS as well, to kind of partition off the front and the back as well. So yeah, so there you go. So you've seen the proxies, and then you can see the final result as well here. It's a bit hard to see when it's like this. But what I thought would be quite interesting is to kind of create a few shaders with slightly different settings. So we've got one with displacement here. So this displacement, when I will just switch to the shader now, I'll just come back out. You can see this is still rendering, and I'm going to go down, and I'm actually going to switch it here in the actual authoring stage. So I'm just, and it's still live, so I could switch it to material 1, which is this one, which if you look in here, whoops, material 1, I'm basically randomizing the color on either side and just putting it through some randomization. So as you can see here, there's two material X shaders. So I've got two very different material X shaders on either side, because you can mix between two material X shaders, which is quite nice. And I'm actually randomizing the specular as well. So I'm randomizing one side of the specular, which ranges between, if you can see, some of these look a little bit diffused. If I turn that down and turn that up, like, you'll see that they get very, very diffused. So you can just randomize stuff like that as well. Might be a bit much, but who cares? So we've got three shaders doing slightly different things. They're quite simple shaders as well, but it just shows you that you can randomize the shader using attributes like the ID attribute on the points and the side attribute as well, which is really nice. So this could be published, and we could set this back to a default, like, or 1, which is fine. We can always change all this later. I'm not going to do any kind of thumbnail rendering in this one. I'm just going to hit save to disk. And this is actually live still though, so this is the live version that you can see rendering. So we have the ability to do the side-by-side comparison, and we'll do a tutorial about how we automate the rendering of all instances as well at some point. Just let Houdini wake up a little bit. It's sometimes the viewport gets confused with its render and proxy, and you can see both. You have to kind of refresh, and then it defaults back to the proxy version that we created, but it will still render the high res geometry with all its textures and things as well. So we can just hide the light there. So you're getting these like sweet wrapper things, nice and easy. And if I go back to this section here, like so, this may crash. So I'll just, we're still viewing the live version here, okay? But if we just disconnect that, so if I just disconnect that, this is now reading from disks, so we have the option now. I did rotate this around because I just wanted this orientation to be this way up for this presentation. And this whole thing here is not going to be saved out. It's literally just a setup to see how I can randomize them with different methods, I guess. So the first thing is you can choose the master variant here. You can actually choose the variant here. So I could say this is the model variant, but I could add a material variant here, or I could do that down here where it's set variant. And what this will do is this expression will actually just randomize all of the variants as well. So it's quite nice. You get a bit of randomization over each one as well. So you'll have a randomization of variants. So there we go. So we get this randomization of all of the materials. The other thing we can do is we could use an assign material variance, and you can do it that way. And this one actually varies. If you see down here, you have to set this to, by default, it'll be set to all. But if you set it to just the full render, you'll see it'll take the rendered geometry of each one here, like so. And then you can say stronger than descendants, and you can randomize the shader assignments now on top. So again, quite interesting, right? So we can turn that off, and we're now looking back at the original variant. So the next thing we could do is we can go in and we can enable this attribute, and this is looking for a well, this expression here is just going to randomize the color attribute. So we don't really see this, nothing's happening at the moment, and that's because one of our shaders only supports this, I think. So maybe is it this one in here? So let's just take a look at, it's probably material 2. So just wait for that. And if you remember, we're no longer live, so we could just hook that back up again, wait for that, and you can see material 2 is now live and traveling down into here, and it's been modified by this attribute here. So it's kind of taking the one side of this, and it's being randomized using this expression, which looks quite nice. So yeah, so there's tons of things you can do, and then there's a bunch of other methods here that I was exploring of randomization as well. So you really can randomize a lot of things. So the first one I've put into a switch node, so we can say the first one is the material internal. So I'm going to go in, and as you can see, I've done the same thing. It's labeled incredibly stupidly. It should be labeled like this. It should be labeled something that makes sense, like that. Or we can randomize the color on top of that, like that. Or we can switch over to this stream and use this attribute wrangle and do it this way as well. So there's quite a lot of different ways of randomizing an attribute, like in this case, the color attribute in our shader. So I quite liked the blue, so we can just go back up here and see that there. So we can now switch this over and we can go to the attribute wrangle method here, so we can write a bit of excuse me, vex in here, and we could even promote this seed value and change this, and this will change the color. Nothing special there. And then we'll move over to this next one, and this is basically a parameter value here, very similar, where I'm basically just randomizing. So I could again just randomize that, and it should change all of the color. So you could imagine you can have loads of these. You could have one that's like a primval that you promoted in your shader for like specular roughness, and you could do that as well. Then the last one is the material variation color. Is that going to work? Again, it's the same thing really, but I've promoted the seed now, so I could just have a bit more of a user-friendly experience. Whoops. So there's a lot of really cool things that you can do, like after the fact. You've arranged your assets as well. So as long as you, and the nice thing is, because this is live, I can kind of go back in and I can look at like the particular shader that's being used, the variant, and modify inside and just make loads of nice little subtle changes as well. And then when I'm happy, just save this to disk so that everybody else can pick that up. So this is kind of how I did like the LOOKDEV for these things in here, like so. But you may notice there's displacement on this one. So if we just quickly go back and we switch this to, let's have a look, to the off section up here, so it's traveling up here, and then I'm just going to turn that off as well. In fact, no, I'll leave that on. That's not going to affect us at all. So if I just switch that back on, we should hopefully get this. So I think that is actually, well, I can tell you that is material 2 here. So it's telling me that's material 2. So because this is live, we're going to traverse back all the way up into here, into the library, like so. That's material 2. And you'll notice there is a triplanar map here with a diffuse map that's been copied across each kind of axis, really, and that's coming in from this op colon, and that's going into my textures in Copernicus. So this is feeding into the displacement map. So all I did was I created a Copernicus network right here, and I created a might need to, let's see if I can find my COPS viewer. Here we go. I created this just using a whirling noise pattern and some fractal noise, and then I just distorted it, and that was it. I didn't even do anything else really. I did create a couple of other patterns, but they didn't really get used. It's going to do like a fabric-y type thing as well. But the idea was just to get this signal out. So you copy this, and then you come back into the shader that you want, and you just paste it in here, and then in front of this you put this op colon, and then I'm just referencing this across here. So that just does like a triplanar displacement map, all live from within COPS. So that's pretty much what you get when you render this. So you get this kind of weird like tinfoil or sweetie wrapper thing going off in there with some variation, kind of fairly believable. But I literally just spent like 2 minutes on it. So yeah, so it's kind of like the the LOOKDEV's authoring of textures and materials in here, and this is just like a little presentation thing here that we could just jump in and out of. If I actually link the view, that would help. Oh, what's going off there? Oh, okay. Some weird nonsense going off. So yeah, it's kind of, that's pretty much as simple as that, really. So I'm hoping that's not too it's just a sandbox area for me. It's just like a way of look deving everything before I kind of send that out to lighting, or to whoever else picks it up and does something before they send it to lighting. In here is another COP network, and you'll find just an input. I've just gone to, is it HDRI Haven, and I've just converted one of their images to ACES CG, and then just saved it out. You may notice an expression, a Python expression in here. That's just a little Python expression that I wrote to automatically save it to the same place, but basically call it underscore acescg.exr. So that's all that is. So you can take a look at that. In fact, the scene will be on Patreon anyway for download. So, and it's just one of those little utility things that saves a bit of time. So that's pretty much it for the LOOKDEV scene. So next we'll be jumping over to do some effects where we will basically go and pull in the asset that we've made, and then do some simulations, and then we will eventually just light it, right? And we'll take what we've done from effects, which doesn't exist at the moment, and light it and see what we get. Okay, welcome back. Thanks for sticking with me. So we've gone through the asset stage where we've created the model procedurally and we've sorted some LOOKDEV out. So now have a USD asset we can do something with. So normally I would have a layout section and I would lay out everything and make sure the camera looks good, and I would kind of set all the props up and everything. But we're just going to dive straight into effects, and I'm going to use the effects department really for doing a bit of well, layout, I guess. But we'll just jump in and I'll talk you through this kind of setup here. So we bring in the asset here like so. So the actual reference, this is actually being read in from disk. So if you really wanted, you could copy and paste the results of the LOOKDEV USD asset, which if you remember back up here, this section right up here like this is the output. So we could make sure that we have copied this if we wanted, and rather than doing it this way where we just navigate to the USD asset, we could paste relative reference, so it's always linked, so it'll be the same thing like so. The control is not actually being used at this stage, so we can remove that. So what I want to do now is just make sure that I basically create a bunch of, I want to basically create all of my variations down here like so. So this is basically what I'm going to be trying to do, is just find the model variant. So like we have in here, we have the variant, it's called model, and if we right click you can see there's model and material. So you can see I've added an extra material now, but I'll talk about that in a bit. It's just another color variation. We're going to put everything into the explore variants. So this is exactly what we're using. We're using the asset name. So I'm essentially saying anything in heart, give me the explore all the variants at the origin. So this just creates every single one, like so. And then I'm going to create a collection. And the expression $OS is just going to name it after this. That's all. And then in here, I'm just basically grabbing anything that's got a model variant, anything within this model variant. So it's just a little expression here. So what that essentially does, if you click on the collections, you'll see down here, it's done the includes. And because of this variant, modulus variant model, it's looking for anything within this model variant just of that type, just basically making a list of them all down here. So I've got a collection that I can refer to. So because I want to instance them like so, like that. And the way I'm doing that is the points I'm instancing on are actually external. They're here, and I'm doing this because I quite prefer to do it this way, because sometimes I use point instancing for one method, and then sometimes I'll use instable reference for another method, and they both have advantages and disadvantages. Mainly the instable reference is because we're going to use this with some dynamics, and we could just then use the drop LOP to do some dynamics later on. You can actually change this. It's all changeable, but I'm just experimenting with things at the moment. So if I just quickly go through here, you will see that I'm putting the instances into FX instances. I'm doing the same over here. So this chain is just a bullet simulation, which I'm using like in a SOP modify. Now there are many ways of doing this. This is not the most efficient way. I do have a video coming soon of the best ways of doing things, like with the RBD procedural and emitting and fracturing objects that you've brought in from randomized emissions from USD and back into bullet into SOP world and then back out again, and that's a much bigger topic. So we're just going to use some of the very quick like built-in functionalities that sidefx have provided, just to do little bits of layout and things. And I think that's why they've made things like the drop LOP and things. So here we are instancing. So I'm creating the instances are going to go down into FX instances. They're going to instance across to this guy here, so you can see it's pointing to this output. So inside of here, I've got a couple of shapes I didn't use, but I've essentially got a tube. So interestingly, you can see the instances, but if I just hide, it's because we're viewing this. This is what we really have. It's just the points here. So I created a tube, and I've just stuck it onto the origin, and then just moved it up a little bit. Then I've done a grain source like so. Just press L. And then a little bit of a point jitter just to give a bit of randomization. Then I did a random orientation attribute. And then while I'm testing, I sometimes cull the points as well. So I can cull the points without changing anything else. But I didn't really need it at this point. I do a little bit of a multiply to the actual scale, because the P scale is established initially by the grain source. So the grain source is kind of establishing the P scale up here, and then my P scale essentially just adds a bit of variation. So it's just saying make some a little bit smaller. That's all. So nothing there. And then there's an ID there, and then a seed, which is questionable really, because you could do that elsewhere. And then I'm creating this randomize attribute on here, which again is just for shading, which we discussed in the LOOKDEV section. So that's just in case I wanted to change something later on, I could do it here. But again, this isn't really a layout and an FX thing. So we essentially just have the points. And then what I'm doing here is I'm just importing my asset. So I'm just importing just one of them. I'm just importing the proxy. And I'm just copying it on. So essentially that's the SOP representation of what we should be getting in LOPs. So this gets sent out into LOPs. So I press U and you get exactly the same thing. Look, now you get this like instancing happening within Solaris using the LOP nodes. So the prototypes, I'm using the second input, and there's this module, and then there is this kind of default color. So this is linked, as you can see here. So I'm just linking this into here, so that just keeps it a little bit more procedural. So I just get a collection that I constantly instance, and that's kind of happening down here as well. Exactly the same, but these are actually point instances. So you'll see that you'll only see the prototypes, which will be all 40, so 0 to 39 prototype variants. And in here, we're going to use inspo reference, so you can actually see individual. I just select this, and I'm selecting component because the primitive type component. I think you could still use group as well, but you can see you have access to individual ones here, and they're named heart simply because I've created a base name called heart, and then you can put expressions in here to name these what you like. So that's basically what we have here. I'm then going to just save this out because I always find it's a little bit more stable if you just lock down your input instances. And then I'm just going to bring them in as a reference. So we are now just reading this in. And then I'm going to add a collider in here like so. And collider is just a grid, basically. That's it. And I've just given it a name. I was playing around with some other things. They didn't really get used. So it's literally just the grid and it's going to the output. So essentially we could clear all that away, and it's simple as that. I just press L to make them tidy, press U to go back up. So that's going to be the collider, and then we can actually prune the collider if you don't want to see that. It doesn't stop it from working in the simulation later on. It's just we just want to output. We don't want to output the grid or anything. We'll let lighting add a grid or whatever. So I'm going to create a layer break now. And then I want to, in the effects, I just want to move them down a little bit. I felt like I needed to move them down. And then an edit LOP. Like so. And all I did was when I did the edit LOP, I'm going to attempt to do this again. It's quite flaky sometimes, but I'm going to see whether I can get this to work. But you press, I think you kind of select everything and then press edit, and then it's going to process into the edit node here. And then what you can do is click on use physics here, and it should toggle physics on. So this edit LOP is going to be using physics, and then if you click add physics, it will tick all of these. So I think if you click add physics, it will add these in to be dynamic pieces of geometry like so. And then if you just select these like so in the edit, we should hopefully be able to scale. Press E to scale, and we should be able to scale them in, and they should start to kind of respect the dynamics because these have got a simulation mesh, so you can see they're they're hunched together. So if I just display the there used to be draw simulation. There is a simulation geometry. If you remember back in the modeling department, we authored a simulation, convex simulation geometry, which is what you're seeing here, and this is what the edit tool and the drop LOP use. So that's kind of nice because I can do this and then what's happened to it? Oh, there it is. I can then just move this down as well, and it should, if it's working properly, collide with the floor as well. There you go. It's just kind of squashed it onto the floor, and then that's that. Okay, so that's kind of what I did with the edit LOP there. So it's really, really powerful. So I actually did something very similar in this version, which is what I had previously. And then the drop LOP, it's got its transformations. If you don't know, the drop LOP's really quite an elaborate little node, which is very powerful, and essentially it's trying to wrap up quite a complex system, showcasing how you can bring in USD assets and really just pull them back into the original Houdini dynamic DOPS and do some simulations and take the point transformations back out and all of that. So I'll delve into this very briefly. So the active primitives are going to be declared. So I'm just going to grab everything in here like that, and I'm going to delete and start again. So hopefully this should just there we go. So it's just basically not doing anything. I'm going to create a little bit of drag and a lot of friction because I don't really want them. I'm not going to use the full simulation, but I just want to drop them a little bit more. And then the passive primitives are the CLDs, which is in here, the floor collider, which is what we kind of established up here like that. So the reason this is unlocked is I'll just play this. It's fairly quick. I'll just hit reset and I'll just play this, and you'll see they should just simulate and they should just fall in a very small pile. Now we're not playing with constraints. It's just a very basic simulation at the moment. So this is going to simulate, and it should cache as well. So it should, there we go. So it's kind of just falling. So at any point we can pick a frame we like, and you can see we've got a nice proxy viewport representation, which will be switched over at render time. So it still renders the full thing, the full render geometry. There you go. So there they are. Obviously there's no lights, so Houdini by default puts a spotlight behind the camera, and it's almost like you have a camera, you're holding a spotlight constantly, so until you add an environment light or anything like that. So we can switch that back over to this guy. So we pick a frame we like and hit stash transformations, and that will be your new shape. So it was just that I just wanted it just to fall a little bit like that, and then I wanted to stash the transformations, and now they are like locked, and then we can now just publish this as a USD A asset, and we can pass that on to anybody else. So we've just got a little kind of, well, we've gone from bringing in a collection of our assets to scattering them, then to making a minor adjustment and another adjustment, and then the drop LOP just to give it a hint, and there we go. So we've got this there. So if you find you've got a lot of these, and I'm not going to destroy my humble MacBook Air, the AM3, it's the lowest spec you can buy, but all of this was set up on this. So when it comes to hardcore rendering and simulation, I tend to just save this. It's in my Google Drive. I tend to just append PC and then just do the simulations over there. This just allows me to set things up on the fly, or if I'm just being lazy and I'm not in the office. So if you go inside this, you'll see, oh, it doesn't look too bad, but there is quite a lot of things going off in here that you might not be an effects artist, you might be a layout artist, you might not need to go in and look at all this, but this is quite a complicated system. But the actual .NET is right here, and it's bringing in, as you can see, it's bringing in the dynamic and the passive objects as packed objects. And then if you wanted, you could do a little bit more simulation work. As long as you work between this, you can do it in here if you really wanted to. I've found that if we come all the way down here and we hide anything above, this will be super quick. I know it's cached already, but the performance will be super quick because it's just giving you the direct bullet simulation. So you can essentially play this through and then leave it on the frame you like and press it up like that and hit stash, and you'll get a better performance. But we don't need to do that. So essentially that's that section there. And then the other option is, again, I saved out this time my point instances and referenced them back in. And this time I'm extracting the instances like so. So they're now like, I can extract them and I can select individual ones. I have a collection just for choosing the instances that I want. So you can see it's a bit hard coded and a bit messy, this, but you can automate this. But this is just essentially saying these ones are going to be what I want to do some simulation with. I'm just creating a collection for those. So somewhere along here there's a collection, and you can see it's kind of like roughly the same thing. I'm just going to configure this USD layer, and then this is the SOP modify. And I've chosen to just pull the whole thing into SOPS. Now this again is not the most efficient because we're essentially going to do the same thing. So they are now all in SOPS. So I've set up a little system here where I could bring in the the actual the purpose here. So on this side we're looking at let me see if I can on this side we're just looking at the proxy simulation geometry like so, and this side it's got the render and the purpose for the proxy all like kind of in one thing here. So I've just split them out because I want to just basically create a name. The control is not really being used, but if I need to do any fraction or sim, I will just pull attributes off of here and use it. I'm going to configure the bullet solver excuse me, like so, and then I could just press play on this and it simulates. So slightly different result, but you've got full access now to all of the kind of rigid body tools. Then I would just save this out somewhere, so I just save this out. So I only save the points, and I actually only saved 1 point, 1 frame. I didn't really need to, I'm kind of replicating what the drop LOP does. I then send out the points, and then it's just a case of taking the purpose, the render, and the proxy, and I split them, and I've got the proxy and the render, and then I do a transform pieces. So you can see I'm transforming the proxy, and I'm transforming the render geometry, and then I'm just copying attributes back across. So you might need we might need to do a spreadsheet in here to kind of help see where we're going, or you can change desktops and go into your preferred desktop. So where did we leave that? So we want to just set that to 1, because obviously you're in the SOP world now. So USD, it needs the path and the name. So, and with bullet, it just needs the name. So I kind of just renamed all the geometries using the assemble node. So if you see here, we've created a name attribute called piece, and then I do the same for the proxy. It gets the same name, and I do the same here, like so. And then later on I just copy back the original name, so it just gets the same name back on either side, so what goes in comes out kind of thing. So we should have like both names and an associated path. So this, if I can just, so you can see it says proxy there, and then this says render. So essentially what we'll end up with should be the ability to preview this, and then when we render it should still switch this out to the high res ones as well. So it's just that I have other ways of doing this, more efficient ways, especially when it comes to fracturing lots of data and emitting things as well. It can get a bit heavy on that kind of side of things, especially with the new RBD procedural as well. So that's essentially doing that, and again that's another option to play around with here. So I kind of side branched a little bit and just saved this out as one frame. So if you bring in the original reference, and you can do a sub layer, and you can see now you've got the new positions. However, I didn't really need this for now, and there will be other tutorials where I go quite in depth. But as you can see, this method was quite nice for just doing like a kind of a layout thing. So we saved this out. So if we had this here, we can copy this parameter, and then we can finally, even though I've used effects really as a layout section, I hadn't really planned on creating piles. I was actually going to do like load of fracturing and spinning around, but it just ended up becoming this, which is more of a layout task. But hey, it doesn't matter. It's just me on this project. So if you go now to the lighting, you'll see I've set up some lighting. So this is pulling in the effects pass straight out the box. It's pulling in before we did anything. It's pulling in the reference, and then I've just brought in the actual the results. I've just sublayered that on. So I'm actually just referencing in what I'm referencing in here is just this. So I'm actually referencing in this before, and then I'm sublayering on the final result. So you could just bring it in as a complete USD asset as well. It doesn't really matter. I'm then setting a variance. So if we render this with no lights, I have the ability to change the variance after the fact we've simulated. And you may notice there's material 4. I actually created this material after I'd done all of this. So I was rendering everything, and then I went back into my LOOKDEV section, I copy and paste, I did some changes in my material, should I say, in here. I did a copy and paste of material 4. I made a few changes. I made a different material for some reason, and then I copy and paste and plug that in, and I published this. And then I just quickly went back to my lighting, and I was able to pull in the version 4 and it was there, and the simulation's intact. So I think this kind of showcases how powerful the non-destructive process of USD is. We can do a lot of material variations again like we did before if we need to. So I could do things like change the colors. It depends what you want. You know, we could randomize the variance so it kind of gives you a randomization. Let me actually make sure I'm displaying that. So this is like now randomizing all 4 material variants, and if you remember, it's kind of doing something funky there, so we could then add in color variation on top. So it's you know, it depends what you want. So we'll just go ahead and pick one, maybe that. So I then just added a floor and a quick material, and again it depends on how you want to work, because this and all the camera could have been in layout. You know, the lighting could have just been this, really, if you're working in a very VFX orientated pipeline. So then we've got this lens material that's pointing to the camera, and then we've got this focus system going off down here. Now I'm not taking credit for this. This is taken from a tutorial, so I'm not really going to take anything out of that. I just create a cross, like a crosshair here, just some piece of geometry, an axis basically, and I use that to point my camera, my focus point on my camera. So wherever I position this guy, is where my camera's going to focus, and that's kind of what this expression is. So you'll recognize this. This is from the I can't remember. I will put the link up in there. And then I just animated the another transform here. I parented my camera to this, so if I could just animate the this transform here, and my camera will go there, and then I just prune out the target thing so it doesn't render. Yeah, and the rest is just, I could add some crypto mats in and some utility AOVs. So there's many different ways of doing this. You can do all of this directly in here as well. So you can add your outputs into AOVs here, like so. There's advantages, disadvantages for both. I think these are like non-render specific, I think, whereas these are specifically for Karma, these kind of AOVs. So there's some nice ones like ambient occlusion, albedo. This helps with the denoising process. And then I've got one called AOV comps, which I just basically, well, I'll do a render and show you. I'll just do a Karma render and we'll just let that initialize. So this is rendering with depth of field, very subtle depth of field, but everything is in focus constantly. That's been like it's been focused onto this point here, which is like basically just sitting roughly around about here. So you could always pin this onto an object if your camera and your object are moving and you want a really nice dynamic shot, but with depth of field, you can have the depth of field kind of always stay relevant and you can keep in focus. So this is just the render. I'll just quickly go to my color correction toolkit and can change. I think that's probably fine. But the AOVs are in here, so you can see I've got an ambient occlusion pass that's trying to resolve, and then the albedo. We've got crypto mats, primitives, and you can get very specific with the crypto mats. It's obviously a normal. So I have utils, so I basically do a depth and a position and a normal and anything utility wise. And then for my comp AOVs, I usually just choose the ones I need. Some are a bit redundant, like I'm not using emission and transmission in this. They're just like a default template. And then you can actually do them down here as well, so you can split per light, and you can just really configure this. It's worth looking into these because they're really going to help you when it comes to rendering. So that is pretty much, I think that's pretty much it. So yeah, you can see all the different render passes, so I could see the glossy reflections, and that's that. So excuse me. So then I would just render this to disk. One last thing before I go is you don't, when you render this, you can render straight to disk and it will go to your chosen location, which in my case is pretty much just here, job renders. So it is just basically going to go to the project in here, like with my projects are going to be like in here, and it'll go into renders, and it's a 3D render from Houdini, and then I basically have my renders going through based on the department. So the LOOKDEV, I did a few kind of renders with the, where are you? This is a nice little app, but you can actually, they're the LOOKDEV renders I did. Yeah, so you get the idea. Did I just close it? So you can kind of change this up a little bit. And then this, as we speak, is rendering on my other machine. So it's probably, you'll probably see frames appearing. So if I just grab this and pop that in there. So we now have a procedural asset that has just been generated, and we've had some interaction and made a nice little pile of Christmas chocolatey things. I have no idea what they are, but I'm hoping that this tutorial you can kind of see a few little tips and tricks in there. I'm certainly learning a lot as I go through all the different areas, so it's quite nice. So yeah, I would just send this render off, and I like to, depending on how powerful your machine is and whatever, you can actually render it to mplay, but that won't save to disk. You'd have to save that afterwards, which is very dangerous. You could render straight to disk and it will freeze Houdini, but it will render to disk, and then, or you can render to disk in background, which will do the same thing, but you'll still be able to interact with Houdini while you're doing that. And if you enable mplay monitor when you render to disk or render to background, it will actually bring up the render in mplay as it renders it on disk. It will show you that as well, which you might like to do. Sometimes I do that, sometimes I don't. I feel the performance is going to be a little bit more optimized if you don't mplay show this in mplay. But anyway, I hope you found this tutorial helpful. It has gone on for a little while, so I do apologize. Forever learning all about USD and all the tools, and trying to figure out how I could use them as a an independent, like a freelance artist. And I'm certainly seeing really cool things across the internet, and it's really interesting to see, and it's exciting to see how this can be used, because eventually this asset could just be put into Unreal Engine and rendered, which is really interesting as well. So we'll be doing tutorials about taking existing assets and just making them work in something like Unreal Engine as well. All right, well, thank you very much for watching this. The files will be on Patreon. If you're finding this tutorial useful, why not drop a like and let me know in the comments. And if you're into learning more Houdini, hit that subscribe button so you don't miss out on the next tutorial.